Okay, 10.2a. So we're going to do just 3 problems out of this assignment. It's just practicing these formulas for volume of prisms and cylinders. So again, what we're talking about with volume is filling a shape. Yeah, water is measured in volume. A lot of times, baking ingredients can be measured in volume, like flour or sugar or something like that, because they take up space. And we want to know how much space they actually take up. So what you see in your notes, just kind of want to point this out to you here. You've got some formulas that you have on the formula sheet that I gave you. I didn't put all of them. I focused on the big ones. So on your formula sheet, meant to have that already pulled up so that you could look at it. I will cut this part out like I'm good at doing, cutting all the mistakes out of these videos. There we go. So on your formula sheet, I pulled off the main ones. Now there is one general formula for volume of a prism. However, these ones are a bit more specific, and so I kind of like these. Right here, you have volume of a rectangular prism, volume of a triangular prism, and then a cylinder. You also have, again, the area of the bases here, but really we're going to be focusing on just these volume formulas, which take the area of the base, right? Hopefully you can see, here's the area of the base, length times width. Hey, there's length times width. That's area of the base. Here's the area of the base, 1/2 base times, this is the height of the triangle. Hey, this is the area of the base. Once more, the area of the base is pi r squared. Area of the base times the height. So once more, in all of these formulas, area of the base is a component of the formula. And then typically what we do is we multiply by the height. Sometimes with another factor involved, that can happen. So we're going to just practice these formulas. In my own usual, just kind of messing with these notes, we're going to do the very last question first, number 11, and I'm going to give you numbers because I'm messing with this one. So the reason why I'm doing number 11 first is because this is the only kind of this prism, and it's the easiest one. So what I want you to do, 2 things, scratch this out. We haven't learned that yet. Ignore that, ignore that, ignore that. We're focusing on this guy here. So what we've got here, now I know it says y and y. We're going to go ahead and run with that. Let's go ahead and call x. Let's call x 5. And then we'll call y 10. And so this is also 10. So you should understand what this shape is at the bottom here if this is 10 by 10. So your first step with these problems is you have to be able to name this shape. Is it a prism or a pyramid? And then really, again, the 2 main kinds we're dealing with are rectangular or triangular. So what do we think about this shape? Is it going to be a rectangular prism or a triangular prism? What do you think? This is a rectangular prism. Hopefully that's a duh. And again, it's a prism. The easiest way to tell is it doesn't come to a point like a pyramid. Yeah, this is a rectangular prism. So we're going to go ahead and we're going to copy over this formula. It is just the length times the width times the height. This is just the 3 numbers they give you. Volume equals length times the width times the height. It's just the 3 numbers. It doesn't matter what you call the length, the width, and the height. I can call this the length, the width, and the height. It's going to be the exact same thing if I jumble them up. So this is literally just 10 times 10 times 5. Take a second to write this down. So how much volume does this thing have? 500 is the answer. That's 100 times 5. Now, if perimeter would just be inches and area is inches squared, volume is inches cubed, inches to the 3rd. We're going to go over a bit more of that in class. Sorry. We don't know what the units are, but we can call them units cubed. There we go. Whatever the units are, they would be cubed. We're going to go over a bit more in class why it's called cubed when area is the square, the little 2. But we're just practicing the formulas for right now. Okay, let's jump backwards now. That's the easiest formula. Let's go all the way back to number 1. So again, we need to be able to identify this shape. We're looking at our formula sheet here, and we're seeing what it matches with is the easiest way to do it. We got pictures here to help us, but also again, we got to be thinking, do I have 2 congruent bases? Does it come to a point? What is the name of this shape based on what you see on your formula sheet? This is going to be a triangular prism. Again, it's not a pyramid because it does not come to a point. Triangular prism. Yes, there's like points here, but you guys should understand that a pyramid has a bunch of triangles coming to one joint point. This is not what a pyramid looks like. Okay, so I'm going to copy over the formula. I've got 1/2 b h of the triangle times the h of the prism. So these are very distinct things, which is why I like the way this formula is written. Volume is 1/2. B is the base of the triangle. H triangle, this is the height of the triangle, times the height of the prism. There's different heights we're talking about here. So this gets a little bit trickier because you have to be able to identify these things properly. Please take a second to trace the shape of the base or the shape of the triangle that we're working with. Where is the triangle we're working with? Well, we got two of them, and you can look at either, right? That's the whole point. There's two of them because it's a prism. That is the triangle I'm working with. So I got the 1/2. These first two numbers come from that triangle, which is why, again, it says height of the triangle. So 3 and 4 is considered the base and the height of just the triangle itself. The height of the prism now is how tall the prism stands. And so that's why 2 is considered the height of the prism. Yeah, that's how tall off the ground the prism stands. So this is just 1/2 times 3 times 4 times 2. Take a second. What would this be? Let's see. We got 12. Now this is 12. Again, this is going to be, we do have centimeters. But because it's volume, we up the exponent one more time to the third, cubed. Okay. So, again, it's a matter of identifying the shape, finding the formula, knowing what goes where. Okay, we're going to try one more, and then we're going to practice this more in class, but right now you're just seeing one of each kind we're doing for this lesson. So you have to be able to identify the shape. Look at your formula sheet. Based on what you know, what is the name of this shape for number 2? This is going to be a cylinder. We got 2 circles as our bases. That's a cylinder. So cylinder formula, again, we're going to copy it over, is just pi times r squared. That's the area of the base. Times the height. Volume equals pi r squared times the height. This one's pretty straightforward. Again, we know pi is 3.14. Now, I got to be careful here because if you mix up these numbers, you will get this wrong. I've got 8 and I've got 6, which is the radius of the circle. 8 is the radius of the circle because that goes from the center of the circle to the outside. 6 is the height because that's how high off the ground it is. So 6 is the height. Okay, so take a second. Let's go to the calculator here. Let's plug this in. Okay, so this is a lot. This is actually a much bigger volume. 1205 point. This is 76. 76 should round to 8. And again, this is inches cubed. Okay, so in class, we're just going to practice these formulas a couple times. As always, guys, the trickiest part is just not skipping over that first step. You have to be able to say, hey, that's a cylinder. Hey, that's a rectangular prism. Hey, that's a triangular prism. And then you know what the formula is.